Hey everybody, it's Mr. Ryan. We're starting Unit 5, Lesson 4, and this is all about understanding decay. So previously in Unit 5, we've talked about what it means for things to be exponential and wrapping our heads around that whole idea. And now we're going to continue with an idea specifically about decay. Before we do that, let's just get ourselves noticing and wondering, get ourselves thinking back into just looking at how two different tables can grow. So before we get to decay, let's focus on things we're more comfortable with, which is when things are growing. So we're asking you, what do you notice? What do you wonder? You could probably wonder any range of things. I know I always wonder really two things when it comes to looking at tables. One, is the pattern going to continue? Is that going to be certain? And number two, what's going to happen when we get to really big X values like 20 or 40 or 100? I'm always curious about those things. But let's talk about some things that hopefully that we notice from these two tables. First thing, probably, is you always like to look at where things start. So when it comes to looking at where things start, in both of these tables, we know when our X value is 0, that's really where we have our Y-intercept, and that's where we start. So it turns out that both of these tables start at 0, 2. Okay, and then we'll kind of see what changes from there. Well, the first thing we always might want to notice is that look at all of our X values. They're going up by 1 each time. So our X values increased by 1. And the same thing is happening over here. So there's some consistency there. So that's a good thing to notice. So now that we know that we have a starting value and our X values are kind of going up consistently, we really want to look at the Y values. So how are things changing? So let's look at table A here. We start at 2 and go to 3.5. So we're adding 1.5. And then from 3.5 to 5, we're adding another 1.5. And then from 5 to 6.5, we're adding another 1.5. And sure enough, we're adding another 1.5 here. So each time the Y values are getting bigger, but it's consistent. So in this table, we are adding 1.5 each time. Okay, let's jump over to table B here. Well, we start at 2 and we get to 3, so we're adding 1. But then we start at 3 and go to 9 halves, which is 4.5. So now we're adding 1.5. Then we get up to 27 over 4. So 27 over 4 is 6.75. And from 4.5 to 6.75, we're actually adding 2.25. And then to get up to 81 over 8, 81 over 8 is 10.125. Interesting. From 6.75, we end up adding 3.375. So we're not adding consistently. So what it looks like here is that we're adding more each time. Now, let's see if we can actually see a different pattern here. Well, the thing I want us to notice is that actually, instead of we're adding more each time, but really to get from 2 to 3, we times by 1.5. And to get from 3 to 4.5, we times by 1.5. And to get from to the next one, we're actually timesing by 1.5. So we have this two different ideas here. In table A, we have what we call a common difference, meaning from each time there's the same difference between the next point. It's common, it's consistent. So we add 1.5, add 1.5, add 1.5. In table B, because we notice that we're not adding the same each time, we're actually adding more. This doesn't even look like the word more. We're adding more each time, but what we found was that we're actually multiplying. When you multiply 2 by 1.5, you get 3. And when you multiply that by 1.5, you get 4.5. And when you multiply that by 1.5, you get 6.75, which is the same as 27 over 4. So we actually have, we've talked about this before, but we have what's called a common factor, which means we multiply by the same each time to get our next y value. So that's kind of our big differences here, is we want to think about transitioning from the idea where we deal with common differences, like when we were talking about lines and slope, to now talking about common factors, which is really where we're going to have this idea of where exponentials come into play.